Hello there. Now, before building the context layer on the SAP HANA Vector database, it definitely pays to understand what are actually vectors. Now, a vector embedding is a list of numbers, 768 to be specific in the case of SAP HANA's embedding model. Now, the goal is each of these numbers encode a fragment of semantic meaning. And in the process, two similar positions or two similar chunks for whom you have the vectors point in the same direction in the 768 dimensional space. Now, this is a little bit complicated, so if I have to simplify, two chunks of text that mean the same should produce vectors that sit close together. Now, let's say, for example, you are in a vacation and you're looking for the museum, and you ask somebody, hey, where's the museum? And they point to the museum. And if you point in the right direction, they're going to say, yeah, that's the way. If you point somewhere else, they're going to say, no, that's not the museum. It's right about here. So it's the same idea. So if you have to pictorially see here, you see that these two vectors sitting close to each other talk about the same topic. And these two vectors sitting here talk about a similar topic but away from this topic. So that is the whole idea. And here we are only taking two dimensions, only x and y, two dimensions. But the actual data is going to be across 768 dimensions. So it is a bit challenging to imagine 768 dimensions. But in a certain format, we can do that, and we'll take a look at it. Okay, so those are vectors. Just think of it as directions pointing in space across 768 dimensions. Now, what are these dimensions? How do they look like and things like that? So this is an example for dimensions from the chunk. This is a specific chunk we're talking about, and these are the actual dimension. I think these are the actual, I'll double check, but this is very similar to the actual vectors or numbers representing that specific vector. So they're going to be 768 of these. Now let's try to picture this in a little bit different way. Now what we're going to do is we're going to plot the dimensions in terms of its magnitude across the different dimensions, right? So here we have the dimensions. So we have a maximum of 100. Of course, this is going to be 768 when you actually embed this in the HANA database, right? So for example, let's say we have a sentence about CRE remediation. This is how it might look like. Of course, these are not going to be the actual numbers. This is how the magnitude of that specific dimension, each dimension may look like, right? And if you convert this into numbers, you'll get something similar to what we saw previously. Now, if I bring in the sentence B, you can see that it's very close to it, right? Concentration policy and CRE remediation are very close to each other in terms of the meaning, and they're very close to each other. So you can see that A versus B, the similarity is pretty high. It's 0.99. And if you see A versus C, let me remove the B and bring in the AUM revenue. Actually, let me remove the CRE remediation as well. So you see that this is different in its structure. It is different. Now, if I compare it to the sentence A, you see that A versus C, the similarity score is not that great. And so is B versus C, because A and B are close in meaning, whereas the AUM revenue, it talks about something completely different. Okay, now if I have to reduce the dimensions, this is going to be something like this. Across the first 25 dimensions, you can see the separation much more clearly. So this is A and this is C. Okay, whereas if I remove the C and bring in the B, you see that the difference is quite small, right? It's quite small. All right, so there you go. Another way to understand vectors. Now, the next is to search similar vectors, right? So how are you going to search the similar vectors in meaning? So vectors which have the same meaning, and there are various ways to do this. One of them is to use the cosine similarity search. So basically you take the dot product of each of these dimensions, for example here. So you basically multiply these different points, and then you divide by the square root of each of those points summed across this 768 dimensions. All right. So let me bring you to the cosine similarity search here. So this is how the search is going to work, right? So for example, if you have a query which is asking about CRE limit, and if you have different chunks, so as you can see here that the VCG risk register has a small angle, then you see that cosine score is about 0.97, which is pretty high. So this is a chunk which is relevant to this query. Now if I bring in some of the chunk, or actually if I go across the spectrum, you see that the angle increases, the score reduces. So this is the proportionality. So the angle increases, the cosine score is going to reduce. All right, and as you see, the similarity also is reducing. So we want the angle to be as less as possible. So if I keep on increasing it, you see that different chunks carry different meanings, and the chunk which is the most recent or most closest to the query is this particular chunk, which is denoted by the angle and the cosine score. This is a quick understanding of vectors, and how we go about thinking about vectors. Just a very quick understanding as to how to get started with.